All right, Ron. Hold, it says preparing to live stream the meeting. I think we can go. We can go.
It says meeting is now streaming live on YouTube.
There you go.
Right.
I think we're ready. Ladies and gentlemen, is it space news time? It's our main stories of the week. Do I have the go-ahead, Tom Totten?
Yes, you do.
All right, we're doing it. Our weekly SBAU podcast every Monday morning, 11 to noon, convening online right here on Zoom to talk space stuff. New launches, discoveries, rovers on Mars, little drones on Mars. We're flying on Mars. Comets and asteroids, NASA, the all-new private space launchers all over the planet. SBAU stands for Santa Barbara Astronomical Unit, your longtime South Coast Telescope and Astronomy Club. Love to have you guys join us. If you eat this stuff up as I do, I'm Baron Ron Herron, proud to be Vice President of SBAU, which not only meets on the first Friday of the month in Farron Hall and our beautiful SB Santa Barbara Museum of National History, that's natural history, up in Mission Canyon, and that is when there's not a pandemic going on. And the museum endorses and supports us. We cannot wait till we can invite you to our second Saturday Star Parties again. So on this 8th edition, episode 8, it is Monday morning, a big morning for NASA, the 19th of April, and it's Series 1, which means 2021. Gentlemen, let's meet the brain trust of Santa Barbara's Astronomical Unit. Now going on 3 years into our third term, Jerry Wilson, President. Good morning, sir.
Good morning.
Things going well in your family and homeowners association, I assume?
Yeah, we're doing good.
All right. Here's your outreach coordinator and one of the best there is, Chuck McPartland. Morning.
Good morning.
The man's wrestling with the technical stuff, and boy, he's great. Technical wizard, former president of the club and webmaster Tom Totten up in the upper left corner, and former Westmont College science instructor, editor of the Santa Barbara Astronomical Unit monthly newsletter, which just came out a couple weeks ago, and an incredible bread maker, I might add. Still to join us, perhaps, Bruce Murdoch. Hello there, Tom Whittemore.
Morning, Ron. Morning, everybody.
Everybody's out with their telescopes at night. Can't really watch Mars close up, but did anybody hear about what NASA did with the little Ingenuity drone helicopter on Mars overnight? Did that fly or not, Jerry?
It flew this morning.
Did it?
About 3:30 a.m. Eastern time, which would be about midnight our time.
Okay, now
Yeah,
I think
12:50 a.m.
I brought this up last week, and I'm not sure what the bottom line answer was. Have we ever had video from another planet, from Mars, where we've been more than any other place? It's all been single pictures, hasn't it?
Well, videos are single pictures just shown real rapidly after each other. And they make pictures, they make videos by doing that, by putting still pictures together that were taken actually months apart, and it looks like the rover is just cruising over the surface of Mars. But a live video, I don't think so. I don't recall that.
Well, there definitely was for this mission, because they showed the
That's right.
the sky crane and things.
Yeah.
What? They
The
showed
sky
what?
crane when they lowered the rover.
Yeah, that was a video, not in real time, but shortly thereafter.
Yeah.
Tom, you want to show it now, or you want to wait a little later? We're looking up. Oh no, we're looking down at the shadow, aren't we?
I'll show you one thing. I'll show you the shadow picture. You can see
Here it comes.
Well, this is the shadow one.
Wow.
That's the shadow down below.
Looking down at itself. But let's see the video. I could probably show that one. Well, that's the news conference going on right now. This is the one where they actually showed the little clip of the helicopter going up and down and applaud themselves.
Wow. Is that
And
at JPL, you suppose?
Look closely. There it's flying, and then it's down. So, but actually, I think that actually took 40 seconds, about 39 seconds or something.
Wow. Well, for the benefit of anybody looking in that doesn't know, how do they keep the part that's hanging below the rotor from spinning around in a counter direction? Do you know what I'm talking about?
They have counter-rotating rotors, so they don't have a torque force on the bottom.
Is that all new technology? Has that been done anywhere before?
That's been done a lot, especially Russian helicopters. A lot of them do that.
Oh, they do. Because I know that's
The U.S. has a new helicopter too that apparently uses that.
And it's called Ingenuity.
Yeah. No. I mean, there's one that's on Earth that we use The U.S.
Oh.
military has a new one that has counter-rotating blades.
Oh, those rotors are going 4,000 miles a minute or something, or 4,000 turns,
3,000 RPM.
revolutions per minute.
Correct.
Wow.
It says 2,400 here, but I've seen 3,000.
And it, in 4 pounds, it has a transmitter, camera, all of that, and just 4 pounds, including the legs.
Yep.
Amazing. All right, we'll be talking about it, I guess, from now on. Bruce Murdoch's still going to join us. Did you watch any of that, Tom Whittemore?
Just what you guys have been sending me on email. You mean the little Ingenuity?
Yeah, Ingenuity.
Yeah, I just, Jerry, I think Jerry sent me the little movie and I looked at it this morning.
And he also sent us the word, I think they're telling the world that a little piece of the Wright brothers is up there on Mars, isn't it?
Yep.
Mm-hmm.
What did they put on there? They
A little
actually,
piece,
They
Go ahead,
put
Jerry.
a piece of canvas from the Wright brothers' original wing that
wow.
the family had saved, and they donated a fraction of it to put in the Ingenuity.
Was it pasted on the side of an instrument or something on Perseverance?
I guess it's probably contained inside.
Oh,
it's pasted on the underside of the solar panel.
oh, okay. Someday they're going to, I guess, delineate all the stuff like that that's been set into space. So like the record that Sagan put on the side of the Voyagers. And I guess some of the astronauts of the Apollo series took stuff to the moon.
Mhm.
Took a golf club and a golf swinging club and a ball.
Someday there'll be railings around the stalled, rover and the Ingenuity thing, and tourists will walk up to it and look at the thing that has the railing around it. So,
Wow.
but far away in the future.
Well, another Elon Musk has something to say about it. He's planning. I've seen some incredible videos, as you guys have too, lately, about what it may look like on Mars.
Uh-huh.
All right, this is our weekly, if you will, look at space news, and there's a lot going on. Jerry, where would you like to take us now in the podcast?
Let's go up to today. The
night sky, according to the magazine. Okay.
Yeah, these are quips from talking points I picked out of Astronomy magazines.
Okay,
So
I got my
those
copy here.
Okay. So, yeah, go ahead.
Monday, just above the horizon, southwest at sunset. This is tonight. The
Mhm.
brightest star in the north sky, and it'll be Sirius.
Yeah.
Mm-hmm.
And it's near, I wrote this down, can't read my own writing. It's too, Orion. Oh, it's near the belt.
It's supposed to be the dog constellation, the big dog, and it's following the hunter, Orion.
Right.
So if you follow the line of the belt, it points
Right.
to it.
Okay, we're getting graphics from Tom. So Sirius is one of the big stars of Orion. It's part of the constellation.
Right.
No, it's part of Canis Major, the big dog, but
Oh,
it's
yes,
Orion's
yeah.
hunting dog.
Ah, are we looking at part of Orion with that? I
No,
see that-
So this is the dog following Orion.
Oh,
Right.
the,
One of
okay.
his hunting dogs.
Yeah, they've drawn the asterism here to represent sort of a dog. But usually,
Somehow the word Canis reminds me there's some of the giant stars that would totally engulf our solar system are in that constellation. Are they not? Have you heard that?
Canis
huge-
is dog.
Huh?
Yeah,
Canis
kind of just dog in Latin.
The city
there
is trimming.
are some OB association stars in there, Ron, that are big stars. Sirius is not particularly
Right.
big and hot.
Right.
It just looks real bright to us because we're close to it.
Right. A little more than 8 light years, huh, Chuck?
Yeah.
So there's
So,
the point of this talking point for tonight is that there is a double star in Canis Major near Sirius that it looks like another double star up farther north called Alberio. This is a blue and gold pair of stars if you look at them in a telescope or binoculars. Sometimes referred to as the Boy Scout stars because of the colors. I like to refer to it as the UCLA stars.
I like
But, go ahead.
But it is kind of in the hindquarters, above the hindquarters of Canis Major here. So above Wezen and Aludra there,
Yeah.
kind of make a triangle with them. It's up in that area.
Yeah.
It's also called Herschel 3945.
Right.
Name for a
Hey,
man
Chuck?
named Herschel.
Chuck, did you want to make a comment? As the M41 showed up there, did you want to make a comment on what you call that at star parties, please?
Yeah, M41 is also, there's the Pleiades, M45 in Taurus the Bull, but in the dog, there's M41, which is another bright open cluster, and it's called the Pleiades.
Pleiades.
It's in a dog.
Can any binary system of stars be seen as two stars by the naked eye, or is that just not possible? Not even with telescopes, mostly, right?
Yeah, if optically, just with your eyeballs, you mostly are seeing just optical doubles, not actual binaries.
Right.
But Alpha Centauri, I don't think you can split that by eyeball, but that's probably would be the easiest binary to split.
How about the Hannibal star, the Dipper, Chuck?
But that's telescopic. I mean, you got Mizar and Alcor, but they're kind of optical doubles, I think.
Yeah, that's what I meant. I mean, you can actually see both of them with your eyes.
Yeah.
Yeah.
Now, just for the audience, optical doubles means that they're close to each other in the sky, but they're not really close to each other.
Yeah, that's right. Mm-hmm.
Whereas binary means they're actually gravitationally bound.
Right, they're rotating around each other.
Are there any binary star systems that are closing in on each other and getting faster and faster, and we're going to see them collide? And is that known anywhere in the universe or our port of it?
That's
undoubtedly.
That doesn't happen so much if there are just two stars orbiting each other. There has to be something to take the energy away and slow them down. So there has to be other massive objects in the system, such as a star that's moving away and the other ones can move closer together, or there's planets or something that pass through close to them. But in general, two objects just rotating around each other by themselves will not automatically come together.
In some of the symbiotic binary systems where you have like a white dwarf sucking material off another one, or two stars so close that they're affecting their gaseous envelope, then you can have tidal effects and things where they'll collide, but you're not going to see that optically.
And I conjecture that if it's in a system where there's heavy amounts of dust, the two stars haven't cleared their area of dust, that might take away energy by collision.
Do we know that is this Winter Alberio's pair, are they actually a binary pair, or are they just visual?
They're visual.
Just visual, okay.
Anybody plan to go set up and look at that tonight, since it's advised by the Telescope magazine or Skyview or whatever? Nobody's
not tonight.
If we were doing a public outreach, we'd be looking at it because it's colorful.
Right. We often show that at the Bacara because we have such a great view over the ocean towards the south.
Well, speaking of outreach, as you just mentioned, if you guys have a school or organization that'd like to schedule a virtual outreach involving an online demonstration using Zoom, lots of graphics and photos, contact our outreach guy, Chuck McPartland. It's still outreach@sbau.org, right?
Yep.
That's an email address.
Yeah.
Well, let's go to Tuesday, tomorrow, which is the 20th. And Asteroid 4 Vesta is back in the news, at least space news. It's near Leonis. Is that long for Leo, the lion?
One Leonis. That means a star in Leo.
Yeah.
Okay. Leonis is the star.
Yeah.
No,
and they're on the ecliptic.
Ron, Leonis means that it's in Leo. The star is 51 Leonis.
Right.
But Leonis is not a constellation as such.
It means it's in the constellation Leo.
Right. It's the possessive case of Leo in Latin. Leonis.
Oh, okay.
Yeah.
Just Regulus, the main star in Leo is Alpha Leonis, for example. So,
right. Mm-hmm.
Am I right in saying that if you're going to zero in on any of the zodiac constellations, you're going to be looking low toward the horizon, or am I wrong on that?
Sometimes low, sometimes high up.
Yeah.
Right.
Not now, not very low now.
No. I mean, if you want to look at Gemini, it's way up high in the sky.
It was nearly overhead for us.
Yeah.
But during the summer, the zodiac constellation Scorpio is very low on the horizon.
It says 51 Leo is easy to see with binoculars. I'm about to invest in that, and then I'll let you guys guide me into the telescope world eventually, maybe before the year's out. But people can get outside even with our lighting, our poor pollution, light pollution.
For these kind of objects, stars and star clusters and stuff, yeah, you can do that well from here. They're good objects.
Yeah. I was just going to mention, if I remember right, if you see something called, 51 Leo or 51 Leonis, 51 is short for magnitude 5.1. At least that's right.
No, not in this case.
Not in this case?
Not in this case.
Okay.
I think it's the Bayer designation where they did this, where they started, after they used up a lot of the Greek letters, then they switched to numbers.
Just happens to be a 5.1 and they call it 51.
Yeah, but if you're looking at an AAVSO chart, which is the variable star observers,
right,
then they will tend to put an abbreviation. They leave out the decimal point on the magnitude, and they will put that designation on the star. So that's probably where you're coming from with AAVSO.
Yeah, right, because I used to be in the AAVSO, yeah.
But how many asteroids can be seen with binoculars?
Ooh.
Down to magnitude, probably what, 9?
Yeah, probably.
It's like a tiny star.
Yeah,
it will look just like a star. You can't see a disk, but from night to night, if it's in the right place, it'll move. That's how you tell it's an asteroid. Or if you know the sky real well, you'll see a star that shouldn't be there.
Oh.
The word asteroid actually comes from William Herschel, because the first ones they discovered, including 4 Vesta, they were calling those planets.
Really?
And he said, well, they look asteroidal. They look just like stars.
Yeah.
And so that term ended up sticking, and they called them asteroids.
So Ron, do you have a pair of binoculars now?
What was your question, Jerry? I'm sorry.
You have a pair of binoculars now?
I do somewhere. I think my son may have taken them with him to Pittsburgh, or they're in the bottom of the closet that I haven't cleaned out.
I never have much luck using binoculars on the sky because I move or shake too much.
Yeah. You need to mount them. There's no question.
Yeah, you need to mount them, or I would recommend you spend your money, if you don't have binoculars already, you spend it on a small telescope.
Well, I happen to have one of those too.
Okay, good.
But it sits on three prong, never mind.
Tripod.
I have a question of Chuck, the guy who does occultations.
Yep.
Has 4 Vesta has it ever occulted a star?
Oh, yes, multiple times.
Really?
Yeah.
So have you gone out in your backyard in the middle of the night and looked at some lately? You want to tell us about it?
I haven't seen Vesta do an occultation. I'm trying to think what the biggest one I saw was, maybe Hygeia. But an interesting one campaign I just participated in a couple of nights ago was, there was an occultation of a star by a moon of a dwarf planet.
Wow.
So there's a dwarf planet called Haumea, which is way the heck out there. And it has a moon called Hiaka, and Hiaka occulted a star. And the error bars covered the entire United States. So just about everybody in IOTA in the States was out looking to see if they could catch it. Wow. And it turns out it happened in the north, kind of to the north of the path line. So it was gotten from, I think, Maryland and Pennsylvania. 2 people managed to catch it. So they have 2 chords on a moon of a dwarf planet way the heck out there beyond Pluto.
Wow.
Well, is 4 Vesta in amongst all the other asteroids? Is it in the belt, or is it an anomaly going on a strange orbit?
No, it's in the main belt.
Okay. And it is not a dwarf planet like Ceres?
No.
That's correct. It's not spherical.
Okay. Do they know what it looks like? Is it potato shaped?
Yeah, we orbited it with a probe. What is it? Do you remember the name of the probe? I've forgotten.
Oh, boy.
Yeah. Anyway, that probe. So...
Yeah.
That was the one. There it is. Oh, Tom, you're a genius.
It's a walnut.
Yeah, okay. Did we get the orbiter back, or is it still out there?
No, the orbiter went on to orbit Ceres.
And it's still there?
Yeah, it's in orbit around Ceres, but it's not talking to us anymore.
Yeah.
Ooh, it's not good. Okay, well, a lot of folks in the club will possibly be out there checking it out. Wednesday, you want to go there, gentlemen?
Sure.
While Tom gets us set up for whatever. Concentrating on the darker sky opposite the bright moon. So we're about ready to get another full moon. Constellation Cepheus, the king, with the Garnet star, Herschel's Garnet star. That's the big feature of Wednesday night. Who's watching that?
This is one of Tim Crawford's favorite stars.
Yeah.
Tim, there's a blank space on the screen. If you're listening, you could check in with it.
Definitely a Tim star. And we often pull it in at Westmont just for Tim.
Yeah.
With the refractor. Yeah.
Well, Gary Peterson up in Nepoma likes it too. He
Okay. Oh, it's gorgeous.
Together,
The big red carbon star. Beautiful.
Does the word Cepheus have anything to do with Cepheid, the variables? Or is that
Yes.
They were initially discovered among stars in the constellation Cepheid, so they're called Cepheids or Cepheids.
Right. The first one was Delta Cephei. Yeah, the first one.
Was there an ancient king called Cepheus?
Yeah, king of Ethiopia, husband of Cassiopeia.
Oh, they're both up there.
And their daughter was Andromeda.
Yeah.
So for everybody, the Cepheid variables are a unique kind of variable star because their period is related very closely to their absolute brightness or luminosity. So if you see the star and you time how long it takes to go through its cycle, then you immediately know the luminosity of the star, how bright it is absolutely. And then you can compare that to how bright the star appears in the sky. And between the two, using the inverse square distance for dimming of a star, you can figure out exactly how far the star away is. So it's one of the major, meter
Rungs on the distance ladder.
Yeah, it's one of the major ways of telling how far galaxies are away. And it was who was that guy, Hubble, using the 100-inch. He spotted a Cepheid variable in the Andromeda galaxy and proved that the Andromeda galaxy was outside our galaxy. Before that, it was a hot debate about whether our galaxy was the entire universe. And these other spiral nebulae were inside the galaxy. And he proved that the Andromeda and therefore the other galaxies are outside of ours. And the universe became very big in our concept.
Yeah. And if it weren't for Henrietta Leavitt, he wouldn't have a handle on that.
That's right. A lot of women astronomers have been overlooked for prizes. And
yes. Yeah.
One of them, they're making it up with the, what's that lady's name who's getting a telescope named after her?
Vera Rubin?
Yeah.
Vera Rubin.
Where is that going to be? That telescope? Chile, again. They got the bright sky, or the clear sky, not bright.
Yeah.
Wow. Let me ask about Cepheid variables. Does it matter what kind of star it is? The one in Orion, Betelgeuse, which is a monster, doesn't it get bigger and littler? And
right. Yeah. Cepheid variables are usually yellow giants. They're yellow giants that pulsate. And when I say pulsate, they have radial modes. So they expand, contract, expand, and contract over days, usually days, but it can go a lot longer than that. Okay. And like Jerry said, you can use the periodicity of the star to get a sense of its innate luminosity, and therefore look at the star, measure how bright it really looks to you, and you can figure out how far away it is.
And for Betelgeuse, it's kind of an irregular variable, so you can't do that.
It has to be a very specific kind of star to be a Cepheid.
That's right. That's right.
Yeah.
Let's slide down the talking points to the variable star types.
Oh, okay. First,
a high-level categorization of all stars.
Intrinsic. You're gonna have to lead us on that, Jerry. Intrinsic and extrinsic, two different types. What's the difference?
Well, I think Chuck is our expert on variable stars.
Oh, Tom is.
I study shorter period stars. because I wanted to get a lot of data in one evening, go through maybe 3 or 4 cycles. I study the kind of stars that are variable. Okay, they're Cepheid-like, but I could get about 4 cycles on these stars. Okay, and I studied a number of them with students at Westmont, and we estimated basically. We basically got the light curves on these stars. Okay, there's a light curve. Tom just pulled one up.
And
So on those
intrinsic
light
means
curves, one dot is one person sitting at a scope or an instrument deriving the brightness of the star at that moment.
Right. And some of the best data I ever got was, believe it or not, Jerry, is with that darn refractor with the 8-inch.
Okay.
Okay.
Well,
It has such a beautiful wide field that you could get a lot of field stars to estimate the variation peak and low, peak and low, peak and low with these variables. The particular kind I studied were called SX Phoenicis. So they were based on a star in the Phoenix, which is a southern constellation.
Okay.
Tom,
Go ahead, Tim. Tom, you want to say something?
Tom Whittemore, did you use a camera on the refractor? And
Oh,
you took
yeah,
images?
yes. Yeah. So Westmont had a couple of CCD cameras that we used. We'd have to basically calibrate the camera. They were made here in Santa Barbara, this particular camera. Okay. I can't give you the model. It's been so long since I've done this, but they were very, very, very sensitive. Okay. So we could study stars that were out to 17th, 18th magnitude. Often we didn't do that because the data got kind of shaky. Okay. I typically like to look for things in the ballpark of 10th to 12th magnitude. Okay. As they went up and down and up and down. And the other thing is, I always look for good field stars whose magnitudes are very precisely known, and they did not change. Okay, so they did not change. So I had basically a nice background star to compare these stars with. Okay. The things I did was I was not going for distance when we were doing this. Okay. I was basically trying to get the cycle out. And with the cycle, you could do some physics on the surface of the star and say something about the density of the atmosphere of the star and things like that. So I was not going for distance. Okay.
Okay. Thank you. So anyway, intrinsic variable stars, there are 2 major categories: intrinsic variable stars and extrinsic variable stars. Intrinsic means that something is actually happening to the star itself. And extrinsic means that something else is happening to the star, such as something as a cloud of dust is going in front of it. And that was the case with Betelgeuse last year. And there can be other things that pass in front of it. And so that you can, you get it occulted at that, so the light is cut off for a while. In intrinsic stars, there's pulsating variables, which you can think of as a sphere of jello, and someone touched it on the side and it's still wobbling. So it's kind of how plasmas act like that. Ionized atoms in magnetic fields. There are pulsating variables and like Cepheid variables, and then there's eruptive variables, which experience eruptions on their surface like flares or mass ejections from our sun, only on a much bigger scale. And then there's cataclysmic or explosive variables, stars that undergo a cataclysmic change in their properties like nova and supernova, or like our sun will, it just throws off the outer shell and becomes a planetary nebula.
Right.
Most of these stars are doing it on a long-term basis. They're just constantly getting brighter and going back on you can nail it on a daily.
Stars have a lifetime, and they have different phases they pass through.
Right.
Basically due to the size of the star and how long it takes them to go through the burning different elements. Our star is in its first stage. It's about halfway through it. We're burning the hydrogen and creating helium in the core of the star by fusion. Other stars are burning stages are burning different elements at different times. And the transition from one element burning to the other is frequently a change. When all the hydrogen is used up, the force pushing out on the star will stop and gravity will win and the star will suddenly contract until it raises the temperature of the core and starts burning something else. And then it will slam the thing to a halt and it'll oscillate around a new diameter for a while and settle down on it.
Like
So-
when Jerry first mentioned size there, what he really meant was mass, not
Right.
physics.
Yeah, yes. Yeah.
Everything
I was going to mention
follows-
one thing. In the March issue of Sky and Telescope, there was a phenomenal article on Betelgeuse, which is a variable star. And there was a dimming of that star, an unusual dimming of it in late 2019. Okay. And there was a lot of talk, what's going on? Was it a dust up and this and that? And it's really, no pun intended, this dust up idea is not settled. Okay. It's really not settled. It's an excellent article. If you haven't read it, I highly recommend it. It's just beautiful. And it gives you a sense of these huge, huge, huge stars like Betelgeuse, okay, that are unstable. And the different parts of the star, very different from our sun, very different from our sun. Yes, it has a photosphere and things like that, but it has this molecular envelope and all kinds of interesting structure to it that I was never aware of. Very good article. Okay, just want to mention that in passing.
Well, gentlemen, I don't know if you remember this, but a few weeks ago, there was a story, maybe it has nothing to do with what we're talking about, of something that appeared in the sky, got bright, and then disappeared. Does anybody remember what I'm talking about?
That was a nova.
Is it a nova?
That was a.
The nova.
I think we mentioned it in the show a while back that there was a nova in what, Aquila? I think it was.
Was it in Cass?
Or Cassiopeia, yeah.
Yeah.
There have been a couple actually lately, like about 3 of them.
Okay.
And they're not supernovas. They're not the huge explosions, but they're where these stars have this extrinsic variability where they're sucking material off another star and they undergo an outburst, typically.
Do you know what part of the sky it was in?
Well, there were several, but one was in Cepheus, I think, and one might have been in Aquila.
Mm-hmm.
Okay, so it was the death of a star.
No, not the death, but it was going through a brightness variation.
That would be,
It just flares up. It flares up.
yeah, that would be the case of intrinsic variable stars and eruptive variable.
Mm-hmm.
Oh,
So it has burned up its hydrogen, but the neighboring star is pouring hydrogen onto it until it burns up, until it gets enough on the surface that it can all of a sudden go off like a thermonuclear bomb.
Right. I just want to mention when Warren Rogers, he was a professor at Westmont. I knew and really liked him a lot. When he was when he was a high school student, he studied a very, very famous cataclysmic variable star called Mu Geminorum. Okay. And boy, those things you can't quite predict. They just flare up, get really bright, and whammo, they're down again. These are cataclysmic variables. And I think Jerry mentioned that in one of his things there.
Down at the bottom of this, it points out that U Geminorum is a dwarf.
Yeah, that's a real famous one, Jerry. And Warren did study that as a kid, wrote a paper on it, and became a part of that summer program that we ran for 5 years at Westmont. Not at that time. He was like a junior in high school or something when he did this.
huh. Is the word Cepheid tacked on to all of these stars, or is that a certain type of variable star? Are there non-Cepheid variables?
Yes.
Yeah.
Okay.
And that caused some problems in the early determination of distances because it turns out there was another kind of variable star called an RR Lyrae star.
Yes.
They were mixing the types up. And so some of the distances weren't making sense until they figured out that there were these 2 different sorts of repeating variable stars.
Right. And because of this, when I was a little kid, the size of the universe doubled.
You can tell them apart by their spectra.
Yes.
So going back to, what was it, Wednesday, the Garnet star. The Garnet is shown in the picture. It's Mu Cephei, so not a variable, but appears in the upper right of the image.
Garnet star. Herschel's Garnet.
Herschel's Garnet star. He was struck by the color.
And it looks very yellow in this picture.
Yeah.
Mm-hmm.
Well, is it a yellow star?
No, it's red.
Yeah, it looks like a garnet, a blood red garnet.
Yeah.
But when you look at astronomical pictures, these are all false color pictures.
Yeah.
Depends on the picture, on the filters you used. These, when they're taken by amateurs, and a lot of them that show up are taken in RGB colors, red, green, blue. But for example, the Hubble does not use RGB. It uses a different set that are specifically designed to look at different elements. And so you can't really get these kind of colors, the colors your eye is used to. And that's a continuing, with Hubble, and that's a continuing debate. People say, I just want to make it look the way it really looks. Well, the human eye is not sensitive to color at that faint level. And so it doesn't really have a look. It's all taste in these pictures that are done for artsy look like this one. If it's from Hubble, then it was done for scientific reasons, and the colors can be anything.
Well, there's red throughout the middle of that. That's not what we would see if we were looking through a telescope.
Really, if it was a super big telescope, you might be able to see that, but you generally cannot see colors in these things. The red is usually ascribed to hydrogen alpha.
Mm-hmm.
So, but you can, I've seen pictures of the Rosette Nebula, which is the way I take it, it's dominantly red, but I've seen it green also. So it depends what you like.
Well, I have seen Chuck McPartland's little laptop connected to his computer looking at Orion, and it was all pink. I've never seen that before.
Right, but if you just looked visually through the telescope, it would just look like milk and water, Ron. You wouldn't see the color.
Chuck, it's right behind you there. Yeah.
They can't design a telescope.
Yeah, there it is right there.
Oh, that's it. Okay, so that's the story of the Garnet star. Any other stars named after precious stones that you know of? Is there a ruby or a pearl?
Good question. I don't know.
I think that's the only one I know. But what's does it have a regular name or a telephone number name? Like
there's about I think there's 30 or 40 different star catalogs that each have their, and they've all listed a different ID number for the same star.
Oh. So that's not one of the Messier items, I guess.
Messier is one of the catalogs, but it tends to focus just on faint fuzzy objects, not stars.
Yeah.
Gentlemen, let me do a quick commercial. Even if you don't own a telescope or have a degree in science, everybody come join us. Anyway, we have college professors, retired physicists, as well as folks like myself who just happen to love new space-oriented events and discoveries. So join the Santa Barbara Astronomical Unit by contacting SBAU.org, and we'll let you know soon, hopefully soon, this year maybe, when we're going to be going back. What is that you've got on the screen, Tom Totten? It says Mu Cephei.
Oh, that was showing how big Mu Cephei was compared to our solar system. I just wanted to show our webpage. This is SBAU.org, our webpage for the club. But let me go back to that Mu Cephei, see if I can find that.
That's the newsletter, which we all get.
That's
Tom Whittemore, do you know how many newsletters a month go out online?
Colin sends them out. He'd have a count, but I don't recall what it is.
Oh, yeah, Colin emails a certain number out, probably fewer than 100.
Yeah.
Yeah.
But it's put up as a PDF on the webpage, so it's, people can just download it freely. So you don't really know how far it's been disseminated.
Well, let's rotate down to Thursday. Talk about the Lyrid meteor shower.
Yes, another meteor shower.
Complicated radiant graph or plot or image.
Well, what I wrote down, it shows the peaks in the morning. Best time to spot would be after 4 a.m. when the moon sets.
Yes, because you need darkness for these showers, and that always helps. You always want to look at meteor showers between midnight and dawn, because you're looking out of the front of the Earth. It's like a car going through a rainstorm. It only rains on the front windshield. You don't see any on the back. So if you see meteors in the evening, those have to catch up to the Earth. If you see them in the morning, those are ones the Earth is running into. So you see a lot more of them. And here it's better with a dark sky, so you want to do it after moonset. And that's where they came up with the 4. This is not a very big meteor shower, but it is running all week, then peaking on Thursday at about 4 in the morning.
And this is a very bad star chart. You're better off if you just looked at the 3 bright stars that form a triangle there near the middle top, and that's the summer triangle. Those will be obvious. And then Jupiter and Saturn down below will be quite bright.
Yeah.
But they threw in a lot of clutter here that makes it really hard to interpret this diagram.
Now it shows that, as you asked last time, Ron, why do we name a star a meteor shower that way? You see that there's the word radiant up there in a circle. And that's where all these meteors, no matter where you see them on the sky, they will all appear to come from that radiant. If you trace the line back, you'll get to that little circle there. Wherever that radiant is, that's the point that it's all diverging from as we run into it. So that's, and that's in Lyra, and that's why this is called the Lyrid meteor shower.
Is there a comet name associated with the Lyrids?
I think there is.
It's a long period comet, I think, but I don't remember the name.
You know what astounds me about meteor showers is it seems to me there's very little that astronomers like members of the club can do about documenting it. It's like a lover's night, right? You just count them. It's like going out and checking bird watchers. You can't video them.
Oh no, you can. Now with everybody having cameras and even on dash cams, you can see these meteors come in. And if you see them, if you get pictures from multiple sources, you can triangulate where the meteor is and where it was heading. And then you can go there at the crash site and you can a lot of times find the meteor or fragments of it. Now, the one that came down in Chelyabinsk in Russia, I'm not sure that classifies as a meteor, but it was very big. But it lit up everything, you know, blew thousands of windows out and stuff. And it was taken, there were so many pictures of it on people's dash cams that they knew exactly where it had hit. And they went there and they found some 36-inch diameter or 1 meter diameter chunk that had fallen in a lake. And so,
yeah, and Ron, there are all sky cameras that have this big fisheye lens, and people just leave them running all night long, and then they can make a composite picture that shows all the meteors that happened during the night in one image, and they're usually quite impressive.
some people make a living collecting meteors. They're very valuable. You sell them on eBay for $1,000 per chunk.
Meteorites, yes.
Yeah, meteorite. Yeah.
I know a guy that has one older than dirt.
Yeah.
I've heard that.
Yeah, we all have. But now my understanding, let's clarify it again. It's the tail of a comet that once went across our orbit.
Yeah.
Earth's orbit.
Mm-hmm.
It's a comet or some other body that sheds pebbles or dust or gas, and it leaves that, it populates its own orbit as a big, look on it as a ring around the sun. And then at some point, the Earth passes through a segment of that ring, and that's when you get a meteor shower.
Yeah, it's like a donut.
Donut.
Yeah,
What's
it's not a flat ring or something like that. It's like a donut, like a torus of debris.
But every one of those is probably no bigger than a grain of sand.
There are some showers like that. They're real fast, just zip, little white things that disappear real quick. Those are about the grain of sand size. Some of them are large, like a basketball, and they come in there orange or red, and they show flame behind it, and they'll break up into different parts, and they'll be real long across the sky. Those are called bolids, and each meteor shower has one type that it favors.
Oh.
Yeah, I witnessed one of those in the Utah desert many, many years ago, a bolide. You hear a report, you actually hear it. And sometimes you can hear the thing sizzle as it marches through the night sky.
In fact,
I'm talking about, really dark skies, magnitude 7 skies in southern Utah.
The sizzling sound, I, to my knowledge, has never been settled on what exactly that effect is, but a number of people have reported it. It's not.
Mm-hmm.
Some people claim that they can feel it in their fillings, that it's an electromagnetic disturbance. My understanding,
gentlemen, of a comet is that when the sun hits it, the moisture, the ice thaws. Right? What?
The volatiles.
Follicles. That's your saying.
Volatile.
Volatile.
Things that are volatile.
Right.
Okay. And it just goes out for millions of miles. Actually, it has two, does it not? Most of the comets have two separate tails. Have you heard that?
Yeah.
Why is that?
one tail is made up of ions that are just, you know, atoms basically stripped of some electrons, and one is made up of chunks of dust. So one is, the yellowish looking one is dust, and those tend to follow the gravitational orbit. And then the ion tails get blown and carried by the solar wind because it's charged. And so they have a slightly different trajectory. So that's why the tails kind of separate a little.
And the ionic tail, they're also all the same charge, so they tend to repel each other. So it spreads out.
Well, we haven't landed on a comet yet, but Japan has.
Yes.
Hasn't they?
No, the European Space Agency landed on a comet.
Yeah.
Oh, they did.
Yeah.
We came in real close to a comet, I believe, at one point.
And we dropped a refrigerator-sized piece of copper onto a comet.
Oh, that's right. Yeah. That was quite a while ago.
Deep impact.
Yeah.
Yeah, we actually have a comet in our kitchen, Chuck. It's scouring powder.
Yeah, we have a can of that too.
Well, the Atlas comet is still out there, isn't it?
There's multiple Atlas comets. So,
Oh.
but there's one fairly bright now. What, magnitude 10 though?
Yeah, Atlas 2020.
Okay, well, it's not part of these nightly sky looks. Shall we go to Friday, since we got about 10 minutes?
Yeah, Friday's really cool. It shows there's a lot of asterisms in the sky, things that catch your attention. To me, there's two of them that really look like what they are, and this is one of them, the coat hanger. And the picture that's shown there, the coat hanger's upside down, but you can clearly see the crossbar and the hook goes over the curtain rod. The other one is the Christmas tree nebula. Not nebula, but cluster. That one
coat hanger.
Tree.
There's a really great asterism that's up now. If you look in the kind of northeastern sky after dark, there's a bright orange star there, Arcturus. If you follow the curve in the handle of the Big Dipper, you arc to Arcturus. And if you look in binoculars or a small telescope near there, there's a little arc of stars that's called the Napoleon's hat.
Oh.
It's really pretty cool.
Yeah.
Nice job, Chuck. Yeah, I was just going to mention Arcturus is one of my favorite stars, and I've been sort of like watching it come up, you know, earlier and earlier and earlier each night because, you know, I take Wally around the house, you know, before he goes to bed, our dog. And there was an exercise when I used to teach at City College that we used to do at the museum, planetarium, where a student would focus in on a star one evening, okay, record the time that they saw that star, and like leave a little soda straw or a pea shooter there. Come the next night and note the time that they see the star and the little pea shooter again, okay? And it would always be 4 minutes earlier, 4 minutes earlier, 4 minutes earlier. So but by the time you have a week go by, you're talking almost a half of an hour, okay? Or a month is 2 hours, okay? So I've just been watching Arcturus coming up earlier and earlier and earlier each evening. It's been a lot of fun. Just reminds me of the museum, you know, and City College.
And how quick we move through our orbit.
Yeah, right. Yeah.
Museum, incidentally, is open by appointment, and the dinosaurs are back. And I guess you can only walk outside, but we don't dare get too close on a star party, wouldn't on a Saturday night.
Not yet, but maybe soon, maybe this year. Anyway, but not scheduled till next year for now. If you look on the coat hanger picture, way over on the left edge, there's a little orange or reddish cluster of stars, and that's NGC 6802. It's shown in close-up in the next picture down.
Is that an upside down coat hanger?
Yes.
Yes, it's an upside down coat hanger.
I think it's also called Rocky's cluster, right, Jerry?
Rocky's cluster, yes.
Yeah, Rocky's cluster.
Huh. We know how many constellations there are, 88, right? How many asterisms have we?
You can make them up.
Yeah, that's in the eye of the beholder.
Yeah.
Big Dipper, Little Dipper, Seven Sisters?
Constellations are a form of asterism, yes.
Yeah.
Yes. Okay. Or the summer triangle is an asterism, right? So
that's right.
Yeah.
The whole bunch.
We can finish up with Tatooine.
With what?
Tatooine.
Oh, I didn't get that.
Part of American culture.
Okay.
It's a hypothesized planet from the Star Wars trilogy. It was in the first Star Wars, where Luke Skywalker is what is it, a moisture farmer or something like that? And,
Yes.
it shows two suns in the background. And that means it's an open question whether you can get a stable orbit around a double star system like this. So an algorithm was developed and used for the first time at New York University and University of Washington, or the New York University in Abu Dhabi. So to look at the stability of, not only the stability of orbits around double star systems, but if any of the known double star systems have a stable orbit in the Goldilocks zone, so they're capable of supporting liquid water on the surface. And they've identified about 6 double star systems we know of that are capable. They do have stable orbits, and they are in the Goldilocks zone. So depending on the planet that you're on in there, what other conditions have to be met before you can stand there. But it would be a good remote site to film the next Star Wars.
Kepler 34, 35, 38, 64, and 413. 5 planets all around the star Kepler. Is that what that's called?
Oh, these are different star systems. They're discovered by the Kepler satellite or probe. So they're named after, which ones. They're in order from what Kepler discovered for double stars.
So each one of those is a whole planetary system.
Yeah. And each one of those double stars is capable, and that doesn't mean they found a planet in that zone, but they're capable of having a planet in the stable zone and having liquid water on it.
Are we capable yet of checking out the atmospheres around some of these things and checking out, what do they call the
spectrum?
Yeah.
What? The spectrum, yeah.
Some of them we are, yes.
If, for example, there was oxygen found, would pretty much know that life was there to create the oxygen, they need something like plants, right?
Not absolutely for sure, but it would be a good indication.
Oxygen and water, things like that.
Methane.
A good indicator.
Would the Webb, which is going to be radio waves, be able to give us some of that?
Webb is infrared, and yeah, it should be able to give some of that. That's one of its missions.
Yeah.
Is the Webb, they're supposed to launch it now, on October 31st, Halloween of this year, but it'll probably be scrapped again. Yeah. They got to get it right. There's no way to go up and rescue it like we did the Hubble.
Right. That's right. Yeah, they're being very.
I wouldn't sell Elon short on that.
Well, earlier in the hour, we talked about.
We can't repair it.
What?
Normally, yes, we can't repair it.
Okay, well, regardless, if we did find life, it'd be 500 years ago, because that's how long it took the light to get to us, at least, probably, unless there's some out there on Proxima Centauri. Let me do a quick promo here for the club, shall we, before we go?
Okay.
Eventually, we're going to be letting you know when those first Friday general meetings are going to be held, the second Saturday board meetings, followed by star parties. All going to resume by the end of the year, we hope. Vaccinations done. We're all vaccinated. And if we're in the right color, got to get up to orange. And are we waiting for yellow tier, Jerry, you suppose?
No, we're waiting for orange. We're still in red.
Yeah, we're waiting for the museum to make a ruling.
Yeah.
Oh.
We can't go our own way on this.
I got you. Well, the museum is good to us.
Yes,
we're one of the few.
They support us in key ways, yes.
That's true. Well, I don't know how you guys have not heard the tree cutting guys outside my house, but it's been noisy as all get out here, and it didn't go over my microphone for some reason. There's a chainsaw that I couldn't, it obliterated what you guys were saying.
What's that, Ron? What'd you say?
You must have a very directional microphone.
I guess so. I'm really glad of that, because last week, I think poor Tom had to chase people out of his study next door. Somebody was making noise. And
somebody is at the front door, Ron.
Is that what it was?
I apologize for that. I didn't realize you guys couldn't hear very well.
No, that was different. You had to get up and go answer the door, but there was something going on, your poor wife, Maureen or something. But any idea of what you're going to be looking at tonight, this week? Any of these things we talked about, Jerry?
I'm working on my telescope again, still finishing the last drawing to get the parts made. I'm trying to get that put to bed and done.
Well,
Then I'll be out with a telescope.
okay. Well, speaking of that, Tom, tomorrow night, is there going to be a workshop?
Yes, there will be.
Yeah. Mhm.
How do people sign up for that or watch it?
Yeah,
Go to our
6 to
website.
12.
Are you involved with that, Whittemore?
No, I have joined them at least once. They often do astrophotography, and I just don't know much about that except studying variable stars. So I don't think I could contribute anything, to astrophotography. Again, I founded that whole thing to help people make good mirrors and suggest ways of making nice telescopes and stuff.
Tom.
Yeah.
Let me interrupt you, Tom. There's I think a lady that Joe Doyle he wants me to put her on our list for telescope workshop because she's looking to make a telescope, I think. So you might want to tune in and see if she tunes in maybe tomorrow night, and see if she's mentioning about wanting to get into making a telescope. Sure. Tim's always talking about his mirror still, so Jerry's trying to answer his questions
that's going to go on for a while, I think.
Yeah, some things are very reliable.
I also have gotten emails from a couple that just got a telescope wanting help with it, and I'm going to go help them in about a week because they're all vaccinated. And I also pointed them toward the Tuesday night workshop to, if they had any early questions.
Okay.
We need to get their email address and put them on my friends of the SBAU list so they get notified of that.
I sent them the link.
Okay.
And you've had as many as 7 or 8 guys on screen, haven't you?
Had up to 12.
Wow.
12?
Yeah.
How in the world do you 10 of them want to talk or 4 of them want to talk or
We seem to manage.
Oh, okay. Yeah, well, I enjoy this. Gives me a reason to live on Mondays, and we're down to the wire. And again, you can watch. Can you watch the workshop on YouTube, or do we save those, Tom?
Yes.
Okay, they're saved and archived, as is this. This is number 8, so I guess we'll call the message to a close or call the meeting to a close. Jerry?
See you at number 9.
You got it. Next week we'll convene here again, and thank you all, and stay safe. Keep your mask on for now.
Thanks, everybody.
All right, take care. Bye-bye.
Bye-bye.
Bye.